AI assistants, they seem so incredibly smart, right? I mean, they can write code, they can summarize dense research, they can even chat with us in a way that feels totally real. But there's this fundamental flaw, a blind spot we've all run into. They are just awful at remembering what actually matters and forgetting what doesn't. And this isn't just some simple bug. It's a really deep problem, right in their very design. So let's just ask the question head on. Why are they so bad at this? You know the drill. You correct it on some fact one day, and I swear it makes the exact same mistake the next. You tell it a preference, and a week later, poof, it's gone. Well, the answer lies in this really deep-seated confusion in how they're built. A confusion between totally different kinds of information. Okay, so picture this. Imagine you're pouring all kinds of information, like permanent, hard facts from a research paper, and just temporary, fleeting conversations with a user, and you pour them all into the exact same bucket. That's pretty much what most AIs are doing right now. They don't make a distinction between solid knowledge that should stick around forever and these passing experiences that, should probably fade over time. Everything just gets mashed together, and that leads to what the paper we're looking at today calls a fundamental category error. And look, this isn't just some small bug in one or two random systems. Nope. It's a flaw that's literally baked into the most influential blueprints we use to design AI agents. So let's go ahead and diagnose the problem by taking a look at the current state of AI architecture. Now, this direct quote from the research, man, it just hits the nail on the head. It perfectly captures the issue. Cognitive decay. That's just a fancy term for forgetting. Kind of like how our own memories can get fuzzy. The problem is, these systems are applying that fading process to solid facts. It would be like you slowly forgetting that Paris is the capital of France just because you haven't thought about it in a while. It makes absolutely no sense. And when you look at the leading frameworks out there, this gap is just glaring. So you've got Koala, a really popular cognitive agent architecture. It actually names the difference between facts and experiences, but then it goes and uses the exact same rules for both. It's like having separate computer folders for important tax documents and random grocery lists, but setting them both to auto-delete after 30 days. And then you have JEPA, another huge one from Jan LeCun at Meta, which, get this, doesn't even have a dedicated place for permanent facts. At all. Okay, so if the current blueprint is broken, what's the fix? Well, the paper proposes a new architecture, a blueprint for a much better AI brain that separates all this information into 4 distinct layers, and each one gets its own specific set of rules. So layer number 1 is knowledge. This is for what is true about the world. Think of it as a library of permanent, verifiable facts that can be shared across all sorts of different AI agents. Now, the crucial point here is that facts in this layer, they don't fade away, they don't decay. Instead, they get updated by this process called supersession. So if a new study comes out with a better finding, the old fact isn't just deleted, it's marked as superseded or outdated. This is so cool because it gives you a clear history of what was known and when. It creates this solid, permanent, and shared foundation that current systems are totally missing. It's the bedrock of facts that the AI can always rely on. All right, next up is the memory layer. This is for all the experiential stuff, what happened, what I was told. Now, unlike that shared knowledge layer, this is totally personal to each individual AI agent. And critically, it's designed to fade over time. It follows a natural forgetting curve, just like our own memories do. But wait, what happens to the really important memories, the ones that shouldn't just fade away? An individual experience, like a single conversation, might decay and just disappear. But if a pattern of experiences starts to repeat, it can be consolidated into something way more permanent. And that brings us to the third layer, wisdom. This is for what works, learned from experience. Think of these as learned skills or really effective strategies. For example, the AI might learn, hey, when this user asks about UI stuff, I should check their theme preferences first. This wisdom is durable, it doesn't decay, but it can be revised if strong new evidence comes along and proves there's a better way to do things. And finally, there's the intelligence layer. This one's different. It's not for storage at all. It's the active, in-the-moment reasoning engine. It's like the conductor of the orchestra, It's querying knowledge, it's recalling memories, it's applying wisdom, all to figure out what to do next. And it's completely ephemeral. It exists for one task and then it's gone. Right, so its whole job is basically to show up for a single task, run the show by orchestrating the other 3 more permanent layers, and then vanish without a trace once the job is done. So here it is, the whole model in one table. You can see so clearly how each layer has its own unique set of rules. Knowledge is permanent, memory decays, wisdom is durable but you can revise it, and intelligence is just for the moment. This clean separation, this is exactly what prevents that big category error we talked about at the very beginning. Okay, so this four-layer model, it sounds great in theory, right? It makes a lot of sense. But is there any actual evidence that this is a real problem that needs solving? The answer is a huge, resounding yes. The case is building from all corners of the AI world. And here's the wild part. This isn't just one group's idea. The same core conclusion is popping up independently all over the place. You've got major research labs like DeepMind, really influential voices like Andrej Karpathy, and even everyday developers on forums and Reddit all pointing to the exact same problem. We have got to separate different types of information. They might use slightly different words for it, but they're all identifying the same fundamental gap. And here's probably the most damning piece of evidence. This number. It's from a benchmark called BEAM, which is designed specifically to test an AI's ability to handle contradictions. A score of less than 0.05, that means that when today's systems are given a new fact that contradicts an old one, they fail to resolve it correctly, almost every single time. This is a direct result of not having a proper knowledge layer with rules for supersession. But here's the payoff. Here's the good news. When you actually fix the architecture, you fix the problem. The paper's authors ran a pilot study comparing a standard flat memory system to their new typed four-layer approach. And the results are just stark. On the very tasks where AI fails the most, like contradiction resolution and temporal reasoning, their system shows a massive improvement. This is real proof that the architecture actually works. So let's bring this all home. Why does this super technical discussion about AI architecture actually matter to you and me? Well, because getting memory right is absolutely fundamental to building AI we can actually trust and, collaborate with. If you remember one thing from this, let it be this. Different kinds of information need different rules. It's that simple. You just can't treat a permanent fact, a fleeting experience, and a learned skill all the same way, and then expect real intelligence to emerge from the chaos. We need specific rules for how each type of information is stored, updated, and, just as importantly, forgotten. And that leaves us with this final, just tantalizing question. If we solve this memory problem, if AI can finally learn to distinguish a fact from an experience and wisdom from just a fleeting thought, what becomes possible? Imagine an AI that truly learns from its mistakes, that builds a reliable and evolving understanding of your work, and that never, ever forgets the core principles you teach it. That's not just a smarter assistant. That is a completely new kind of partner.